in this module, we examine general equilibrium of exchange for a very simple economy composed of only two individuals A and B and two commodities X and Y. Now, in this general equilibrium in exchange module, the two households want to maximize their total satisfaction, and what the module seeks to talk about is as to how should the consumer or the economy allocate its endowment of the two commodities A and B, which are not incorporated directly into the module. How should the two commodities be allocated between the two households so that they are maximizing their total satisfaction? This module eventually leads to a situation of Pareto optimality. Now, what we are trying to explain in this module is as to how should the two consumers be allocating their endowment of resources over these two commodities. Now, the technique that is used to explain the allocation is with the help of an Edgeworth box diagram. In the Edgeworth box diagram, the reference to which has already been made in an earlier module, wherein we have talked in terms of the difference between the general and the partial equilibrium analysis. Now, in this particular module, we are considering the Edgeworth box diagram, wherein on the x axis we are showing one commodity X and on the y axis we are showing the other commodity Y, and we are saying that the total amount of the two commodities available are allocated both between A and B, and they are allocated in such a manner that the total satisfaction is maximized. Now, for this purpose we have made use of the ordinal approach, which is the indifference curve analysis, wherein we have explained as to how various combinations of the two commodities are allocated. Each point on the indifference curve would indicate the same amount of satisfaction, and we talk about a series of indifference curves wherein we talk about the options we are moving from the south to the north and north to the south, and we are showing one consumer A and we are showing two individuals A and B. On the left hand side we are showing consumer A, and on the right hand side we are showing consumer B, as to on what basis will the allocation be finally decided. Now, when we move from south to when we are moving up from the left hand side, the indifference curve would, as has already been explained earlier, the indifference curve would show alternative combinations of the two commodities yielding the same amount of satisfaction, and when you go up, the higher indifference curve would indicate the higher level of satisfaction. Likewise, when we talk about household B, which is on the other side, we are coming from above to below. Now, in that again we are showing the same thing.
After studying this module, you shall be able to know about the general equilibrium in exchange, understand how exchange takes place in general equilibrium, learn about the assumption of general equilibrium in exchange, understand the utility possibility curve. General equilibrium analysis seeks to determine the equilibrium in an economy, recognizing the fact of interconnections and interdependence among the different products and factor markets. In this section, we examine general equilibrium of exchange for a very simple economy composed of only two individuals and two commodities. Now we will discuss general equilibrium of exchange for a very simple economy composed of only two individuals, A and B, and two commodities, X and Y. In this exchange system, we assume that there is no production. That is, we consider the case when two commodities are provided to the individuals in the economy from outside the system. Such possessions are called the initial endowments of individuals A and B. Now, suppose the individuals engage in an exchange as to maximize their satisfaction. This process of exchange can be better understood through the box diagram. The dimensions of the box measures total quantity of X measured along the x-axis and total quantity of Y measured along the y-axis. Each point in the Edgeworth box diagram represents all feasible allocations in this simple economy. The total available amount of commodity X is OAF and of commodity Y is OAG. The available amounts of the two commodities OAF and OAG determine the dimension of the box, which is given and fixed. The quantity of X available with the individual A is measured from left to right along the x-axis with bottom left hand corner OA as the point of origin, and quantity of commodity Y available with the individual A measured along the y-axis from bottom to top with the point of origin OA. For individual B, the top right hand corner has been taken as the origin, and with the given quantities of X and Y, the quantity of X available for consumption for individual B is measured right to left from the point of origin OB, and the quantity of Y available for B is measured top to bottom from the point of origin OB. Consider a point N lying inside the box OAGOBF. The allocation to individual A is OA XA of commodity A and OA YA XAN of commodity B, while the allocation to individual B would be OB XB of commodity X commodity and OB YB XBN of commodity Y. Note that OA XA and OB XB would add up to OAF, and XBN plus XAN would add up to OAG. This implicit assumption means that there is total usage of each and every commodity for the economy as a whole. Thus, by construction, any point in the box represents the division of total quantity of X or Y in between individuals A and B, so that XA plus XB is equal to X, YA plus YB is equal to Y. In the Edgeworth box diagram, we also draw the indifference curves of the two individuals A and B, depicting their scale of preferences between the two commodities X and Y. We can depict the individuals' preferences by their indifference curves map.
Now, this entire analysis is based on a set of assumptions, and the assumptions would be that the two individuals A and B are endowed with fixed amounts of only two commodities X and Y, and both the individuals know each other's preferences, and each individual will take prices as given and optimize accordingly. With the given assumptions, the journal exchange equilibrium would be same where on the contract curve. That is, the line which passes through the tangency points lines of indifference curves of the two individuals. As mentioned, at these tangency points of indifference curves, marginal rate of substitution of x for y of individual A is equal to the marginal rate of substitution of x for y of individual B. Any point where the indifference curves are tangent constitutes a consumption point where no further gains from trade or exchange are possible.
Let's now discuss the assumptions on which general equilibrium of exchange is based on. First, two individuals A and B endowed with fixed amounts of only two commodities X and Y. Second, both individuals know each other's preferences. Third, each individual will take prices as given and optimize accordingly.
Now, the question is, how do we determine as to what kind of a combination will be relevant for A and what kind of combination will be relevant for household B? Now, in this particular context, we will have to keep in mind the fact that the consumer is in equilibrium at the point where the marginal rate of substitution, of x for y for one consumer is equal to the price of x and y, and for the other consumer also the marginal rate of substitution of x for y is equal to the price. Now, as far as price is concerned, the price is exogenously determined. We do not talk about the determination of that, we take that as a given. Therefore, what is got to be determined is that each individual consumer will equate the marginal rate of substitution. Now, marginal rate of substitution basically shows the delta y upon delta x should be equal to the price of x upon price of y, and delta y upon delta x would be equal to the marginal utility of x upon marginal utility of y, which in other words would basically mean that the marginal utility of x upon price of x should be equal to the marginal utility of y upon price of y, or in other words the last rupee spent for individual consumers on different commodities should yield the same amount of satisfaction to the consumer. Therefore, what we are trying to show is that in this particular situation, the two consumers would both individually try to equate the ratio of prices of the two commodities with its marginal ratio of marginal utilities, and what is likely to be indicated is that on each indifference curve, if we take the now we will come across a situation in the diagram wherein we would find that the indifference curves going from left to right and coming down will be tangent at some points, and the points where the indifference curves of A and B indicating alternative combinations of x and y where they are tangent to each other, each point of tangency would indicate the same marginal rate of substitution of x for y for the individual consumers. Now, if we take a locus of all these points where the marginal rate of substitution is the same for each one of the consumers, then this curve would indicate the various equilibrium points for the two consumers, and the curve which is drawn connecting these points is what is known as the contract curve. Now, each one of these points, mind you, would indicate a Pareto optimal situation, and this curve is known as the contract curve. Now, each one of these points is in fact each one of these points is an equilibrium point, and the consumer would obviously prefer a higher point to a low point.
With these assumptions, the general exchange equilibrium would lie same where on the contract curve, that is, the line which passes through the tangency points line of the indifference curves of the two individuals. At these tangency points of indifference curves, MRS xy of individual A is equal to the MRS xy of individual B. Any point where the indifference curves are tangent constitutes a consumption point where no further gains from trade or exchange are possible. Thus, the general equilibrium of exchange will occur when the following condition holds good: marginal rate of substitution of good X for Y for individual A is equal to marginal rate of substitution OG good X for Y for individual B. Let's discuss the general equilibrium of exchange with the help of contract curve. Recall the equilibrium condition MRS XY of A is equal to MRS XY of B, which tells us that an efficient exchange is obtained where the indifference curves of individuals A and B are tangential to each other. Let's take a look at the Edgeworth box where x-axis measures quantity of good X and y-axis measures quantity of good Y. The quantity of X available with the individual A is measured from left to right along the x-axis with bottom left-hand corner OA as the point of origin, and quantity of commodity Y available with the individual A measured along the y-axis from bottom to top with the point of origin OA. For individual B, the top right-hand corner has been taken as the origin, and with the given quantities of X and Y, the quantity of X available for consumption for individual B is measured right to left from the point of origin OB, and the quantity of Y available for B is measured top to bottom from the point of origin OB. We can hence obtain a locus of the efficiency points obtained by tangency of the indifference curves, known as the contract curve given by OAM and LOB. Any movement along the contract curve is a gain of utility to one individual and loss to the other. Contract curve itself does not depend on the initial endowment. Contract curve describes all the possible efficient outcomes of mutually advantageous trade or exchange from starting anywhere in the Edgeworth box. Given the initial endowment point, we can get the subset of the contract curve that each individual prefers to his initial endowment. If P is the initial endowment point, both the individuals A and B will be better off at all points between M and N on the contract curve OAM and LOB.
Then the question arises as to which ones of these points actually represents the equilibrium point. Now we'll have to which amongst these equilibrium points is actually relevant from the viewpoint of the consumer. And in this context, like, we have to keep in mind always the fact that the consumer would prefer a higher point on the indifference curve to the low point. He prefers more to less. Therefore, the question is as to which out of these alternative equilibrium points is going to be actually relevant for the consumer as the equilibrium point. And Here we have to keep in mind that we'll have to superimpose the constraint line, and the constraint line basically the constraint line is the community budget, the community budget line, and the point where the community budget line would be tangent to the community budget line indicates obviously the ratio prices delta, the price of x upon it indicates the ratio prices of the two commodities x and y. Therefore, essentially the point where the budget line is tangent, or the budget line is where the slope of the budget line is equal to the point where the slope of the indifference curves for the two consumers is the same.
Let's now derive utility possibility curve from consumption contract curve. By plotting the consumption contract curve from the output space into a utility space, we get the corresponding utility possibility curve. It shows the various combinations of utilities derived by individuals A and B, that is, UA and UB. When this simple economy is in general equilibrium in exchange, we measure A's utility on x-axis and B's utility on y-axis. Note that the points in the Edgeworth box diagram located away from the consumption contract curve are inside this utility possibility curve. For example, point P is inside the utility possibility curve and hence shows an inefficient allocation of X and Y commodities between individuals A and B. Utility possibility curve shows the utility levels of individuals A and B across the efficiency locus for the given levels of X and Y is plotted shown by points MN and L. For example, in the Edgeworth box, indifference curve B3 of individual B intersects with indifference curve A2 of individual A at point M. This is plotted on the utility possibility curve at M. Similarly, point N and L are also plotted. Thus, so far, we have studied that the general equilibrium of exchange occurs at a point on the contract curve where the marginal rate of substitution between the two goods MRS/XY of the two individuals is the same. The exchange equilibrium cannot be at a point in the Edgeworth box which is not on the contract curve. This is because at a point which is not on the contract curve, indifference curves of two individuals intersect each other and therefore in original rate of substitution MRS/XY are not equal to each other. Utility possibility curve is derived from consumption contract curve. It shows the various combinations of utilities received by individuals A and B. When the economy is in general equilibrium, it is the focus of maximum utility for one individual for any given level of utility for the other individual.
Thus, the general equilibrium of exchange will occur at a point where the marginal rate of substitution of x for y for both the commodities and both the consumers is equal. Now, if we connect if we look at the diagram and we find that by plotting all these points of tangency, we will get the utility possibility curve similar to the production possibility curve, wherein each point on the utility curve will show the points of equilibrium, wherein we have plotted on the y-axis the utility of household B, and on the x-axis we have plotted the utility of A. Now, we should keep in mind the equilibrium condition, wherein we have equated the marginal rate of substitution of the two households with the two commodities in question, which tells us that an efficient exchange is obtained where the indifference curves of individual A and B are tangential to each other. We can hence obtain a locus of these efficiency points known as the contract curve, given by the diagram, given by the various points in the figure. Any movement along the contract curve is a gain of utility to one individual and loss to the other. Contract curve itself does not depend on the initial endowment. Contract curve describes all the possible efficient outcomes of mutually advantageous trade or exchange from starting anywhere in the Edgeworth box. Given the initial endowment point, we can get the subset of other contract curve that each individual prefers to his initial endowment. From the above, from our discussion, it follows that given the initial endowment point, the general equilibrium of exchange can occur somewhere between M and N on the contract curve as shown in the diagram. On all points between M and N, the exchange equilibrium can exist, although equilibrium will exist at a point on the contract curve. There is no unique position of exchange equilibrium. All points between M and M on the contract curve are possible equilibrium positions. Utility possibility curve is derived from consumption contract curve by plotting the consumption contract curve in the diagram. Form the output space into a utility space. We get the corresponding utility possibility curve as shown in the diagram. It shows the various combinations of utilities derived by the two individuals. When this simple economy is in general equilibrium, in exchange we measure A's utility on the x-axis and B's utility on y-axis. The general equilibrium of exchange occurs at a point on the contract curve where the marginal rate of substitution between the two goods of the two individuals is the same. The exchange equilibrium cannot be at a point in the Edgeworth box which is not on the contract curve. This is because at a point which is not on the contract curve, indifference curves of two individuals intersect each other, and therefore its marginal rate of substitution are not equal to each other. It is the locus of maximum utility for one individual for any given level of utility for the other individual.